Good evening to all of you. Welcome you guys. Welcome you all. How you are doing everybody? Very good evening to all of you. Good afternoon to all of you. I think we are live. First of all, do check करके बोलिए is my audio video is clear to everybody. Do check करके बोलिए is the audio video is clear to everybody. Right? Is the audio video is clear to everybody? तो आज से हमने इलेक्ट्रोमैग्नेटिक्स का क्रैश कोर्स शुरू होने वाला आज से. So you can do regularly, try to follow this course the same timings. Okay. And सबसे पहले here a great announcement from Unacademy से 12 months का आपका सब्सक्रिप्शन just 9999 से आपको मिलेगा. So utilize these opportunities. So we'll plan it in the crash batch. We'll start now here in that when there we are doing this one special program, one short video. I will continue. I will take the one short video. Will complete those topics. Okay. Right. Now you can see now here January 18 there is an all India mock test is there. With this you will get to know here your performance levels you can able to get. January 18th. So 2 sessions you can have a look at now here. That is one is at 9, the other one is at 2:30 p.m. So utilize these opportunities. With this you will get to know here where you stand in throughout all the all India rankers. And these are the ESC 2025 rankers from Unacademy team. These many dates are the rankers you can have a look at. And test series भी आपको मिलेगा. Test series पर 2026 के लिए आपको मिलेगा. So from the December 15 onward the test series is active. You can follow these courses. And so we starting the new batches we are starting. You can have a look at. That is Dronacharya batch. This is for 2027 के लिए, which is starting from this 8th Jan. So here I'm starting the electromagnetic theory only. I'm going to start at 9 p.m. This course is both EC and electrical दोनों के लिए. And so this 28 के लिए Kurukshetra batch वो भी शुरू होने वाला. So to join this thing you can use the code of BV Reddy and to get this personalized discounts and personalized guidance from me. Right. So Unacademy starters kit. So West Bengal का इलेक्ट्रिसिटी डिपार्टमेंट का कोर्स भी हमने लॉन्च किया. You can have a look at. And officers call interview guidance program. Right. These are the new courses. And another बढ़िया thing is what I'll be now here. Unacademy AI tool. This is Una. So there are the 3 different modes we can see now here. Voice mode, quiz mode, smart summaries. With this you can directly talk to Una. So according to your requirement, it will simply summarize all the content what we have uploaded. It can prepare the test also, quiz also it can able to prepare it. And the test series which is live. And we do offer the 2 subscriptions for GATE and ESC के लिए. That is one is plus वाला, the other one is iconic. प्लस में आपको क्या चीज मिलेगा? टॉप एडुकेटर्स क्लासेस मिलेगा, लाइव डाउट सॉल्विंग, evaluated mains test series, structured courses and PDF, live test and quizzes, unlimited access, इसके साथ आपको आइकॉनिक में एडिशनल बेनिफिट्स क्या होगा, पर्सनल कोच भी मिलेगा, फिजिकल नोट्स भी होगा, आस्क ए डाउट फीचर एंड ऑल द फीचर्स आर प्लस. And so then try to utilize this, to do join these sessions as early as possible so that you will have a great learning experience from the top educators. You can able to complete the syllabus fastly, right? So चलिए आज का सेशन हम शुरू करेगा and try to follow this course regularly. We'll finish this course now here. So around this 1 week we can able to finish complete करेगा हमने, ठीक है. चलो electromagnetic theory. So electromagnetic fields. What the electromagnetic fields is? So this is nothing. This is the branch of electrical engineering which deals about the interaction or the interplay mechanism. Interaction or the interplay mechanism between electric and the magnetic fields. Interaction or the interplay mechanism between electric and the magnetic fields. Electromagnetic field. So here we are going to discuss about the electric field and simultaneously we are going to discuss about the magnetic field. Here we are going to discuss about what is meant by electric field and when we have the electric field, and so how this electric field will affect these magnetic fields. At the same time, we are going to discuss about how this magnetic field can affect the electric field. So this what we can say, the interaction, the interplay mechanism between electric and magnetic fields is called as the electromagnetic fields. Okay. And what is the major source of electric field, you tell me? Electric fields? The fundamental particle which will causes the electric field, magnetic fields, which is what, tell me now? That is a charge. Charge is a fundamental particle which will causes the electric field, magnetic fields and electromagnetic fields. When the charges are at rest, stationary, in that case we have only electric fields only. When the charges are moving, moving with a uniform velocity, in that case we have a magnetic fields. When the charges are moving with non-uniform velocity, in that case we have an electric field. इसके साथ we have a magnetic fields also. Okay. What is the source of electric fields? You see this thing here. Charge. If the charges are at rest, that means static charges produce only electric fields only. Static charges produce only electric fields only. If the charges are moving with uniform velocity, in that case we have electric field and magnetic field, but these electric and magnetic fields are independent. Okay. But when the charges are moving with non-uniform velocity, in this case we have electric field and magnetic field, both will exist. How these two are? Electric and magnetic fields are interdependent. Means electric field depends upon magnetic field depends upon electric field. That's why these are called as electromagnetic fields. ठीक है. So इसके बारे में हम ठीक से हम डिस्कस करने वाला हमारा टॉपिक में. ठीक है. So here अभी हमने बेसिक्स का डिस्कस करने वाला, बेसिक टर्म्स ऑफ इलेक्ट्रोमैग्नेटिक फील्ड्स. So let's talk about the basic terms of electromagnetic field. The first we are going to talk about what electric field intensity. What is the electric field intensity means what? This is nothing but the measure of electric field. So this is what now it is a measure of the strength of electric field at a given point is called it as a electric field intensity. Means for example, I have taken some positive charge we have taken, and this positive charge can able to create certain region. All this region is under control of the charge, isn't it? अगर अगर मैंने कुछ पॉइंट ले लिया इधर एक पॉइंट ले लिया, at this point because of the charge we have a electric field, we have some effect is there. That effect is called it as a electric field intensity. So how we'll measure this electric field intensity? And this could be given as, which is equal to, that is limit. Here we have placed some small charge we placed. Now let us say this small charge I am calling as Qt. Qt is a test charge. Limit Qt tends to 0. That is F by Qt. This is called it as a electric field intensity. The force experienced by a test charge is called as a electric field intensity. And what the units you tell me now here? The force units are newtons, by charge units are coulombs. So that's why what we can say now here? Newtons per coulombs. The units are newtons per coulombs. The force experienced by a test charge is called electric field intensity. This is one unit. We have a other unit also for electric field intensity. The other unit is volt per meter. We use mostly volt per meter हम use करेगा. Right? And this electric field intensity is there now. This electric field intensity which depends upon medium, surrounding medium. Electric field intensity depends on surrounding medium. Okay. Next, electric flux density. Electric flux density means the amount of electric flux lines crossing through the unit surface area is called as electric flux density. So let us consider we have the number of electric flux lines are like this. We have the electric flux lines are like this. These are the electric flux lines. Now I have taken some surface we have taken here. I have taken some surface now which is placed like this. Now through this some other I have taken one small part we have considered. Let us say if we have taken one small surface area we considered, through this small part some other flux lines will cross through this small part now. Some flux lines will cross us through this small part. So these flux lines, which we can say these are small flux, is a d psi, and this will have some area. This area which is equal to ds. I will indicate these directions also. So let us say this is the amount flux lines are crossing. D psi is a flux and this is the surface area ds. And this angle between them is a theta. Then from this we can define this electric flux. From this we can define this electric flux density D, which is given as electric flux per surface area. Okay. So this could be given as what we can say now d psi by ds, and we can use this as unit vector en cap. Right, what this en cap is a unit normal vector. From this is a vector quantity, we can indicate the d bar. So that is d bar, which I can say it as what, tell me now, d psi by ds into en cap with the units of flux units are coulomb. So it is coulomb per meter square. From this we can get the flux through this given surface, that is surface integration of d bar dot ds bar. Then I can get the flux. Okay, electric flux we can get. Next, magnetic field intensity. Magnetic field intensity, like we have used the electric field intensity to measure the strength of the electric field. Similar to that, to measure the strength of the magnetic field, we use magnetic field intensity. Okay, to measure strength of the magnetic field, we use magnetic field intensity. And this magnetic field intensity ka units are what, tell me now, amperes per meter. And this magnetic field intensity independent of surrounding medium. Magnetic field intensity independent of surrounding medium. But electric field intensity depends on surrounding medium. Earlier, electric field depends, but magnetic field intensity is independent of surrounding medium. Okay, very careful, try to remember. Next, magnetic flux density. Like we have seen electric flux density, similar to that magnetic flux density. The amount of magnetic flux crossing through the given surface area. So like we have seen, exactly similar to that B, which is given as what I can say here. This is the amount of magnetic flux crossing through the given surface area. Right, so that is B bar, which is given as what we can say now, d phi by ds, and the direction is given by en cap. So if we consider this as a, let us say, number of magnetic flux lines are coming like this. This magnetic flux lines are coming like this. Now we have taken one small surface area which we have placed now here. I placed some surface, we have placed here like this. So this this part, some of the flux lines will cross. Now you can see. So through this part, some flux lines will cross, right? And that flux, which will be, we're calling it as a d phi, small magnetic flux. It will have some surface area. This is the surface area. Let us say this is the ds and this angle is theta. Okay. So what are the units of this magnetic flux, you tell me now? That is, magnetic flux units are Weber, that is Weber per meter square. The units are what, tell me now? Weber per meter square, or we have a other unit for this is Tesla. Right. So from this we can get this magnetic flux, which is equal to surface integration of B bar dot ds. B bar dot ds. This is a magnetic flux. Okay. So here in the chapter we use, these are the four terms we use. You can see now EDHB. EDHB. So the entire discussion will be happen with these terms only. Electric field intensity, electric flux density, magnetic field intensity, magnetic flux density. These are the four terms we use in the entire the chapters. And you can have a look at now in this. Let us study these things comparatively, electric field and magnetic fields. Look at now here. In this electric field, we use one term that is called it as, what tell me now, first one, that is we use the term called as E. And what this E is, the electric field intensity. What is the purpose of this E? It will measure the strength of the electric field at a given point. It will measure the strength of the electric field at a given point. And what the units of this E is a? So this units of this electric field intensity, which is equal to what, tell me now here? Volt per meter. Units of electric field intensity, volt per meter. And so corresponding to this, in magnetic field we use a term called as H, magnetic field intensity. And with the units of what you can see now, this is ampere per meter. What the magnetic field intensity is? It is measure the strength of the magnetic field. And corresponding to this thing, in electric field we use a term called as a D. What the D is? D is the electric flux density. Electric flux density units are what you can see now here, coulomb per meter square. Electric flux by area. And similar to that, here we have a magnetic flux density, that is B, with the units of what you can see, Weber per meter square. Right. And we have a relation between these two, now tell me. And what the relation between these two you can see now here, that is given as D equal to what you can see now here, epsilon E. D equal to what, tell me now? Epsilon E. Epsilon E. What is epsilon is called it as a? What this epsilon is called as, what, tell me? Epsilon. What this epsilon is called it as, what, tell me now? This is the permittivity. This is called as what, tell me now? Permittivity of medium. Permittivity of medium. And similar to that, in magnetic field we have a relation, that is what, tell me now? B equal to what, tell me now here? Mu H. And when what the mu is called it as a permeability. Permeability of medium. Permeability of medium. And in general, this epsilon, which is given as what element here? Epsilon r into epsilon naught. And where what it is? Epsilon r is a epsilon r, which is called as a relative permittivity. Relative permittivity. And this epsilon r, which is always greater than 1. Epsilon r is always greater than 1. And this epsilon naught, and here we can write similar to that, mu we can write as what terminal? Mu r into mu naught, where mu r is called as what, tell me? Relative permeability. Relative permeability. And so mu naught is called as the permeability of free space. Permeability of free space. Free space, air, vacuum, same thing we'll consider. Here also epsilon naught is called as a permittivity. Permittivity of free space. Okay, and this we can see this values, we can see the here epsilon naught value, and which is equal to 1 by 36 pi into 10 power minus 9 farads per meter, and that is, which is given as what we can say now, 8.854 into 10 power minus 12 farads per meter. And this mu naught value, that is given as 4 pi into 10 power minus 7 Henry per meter. Okay. Right. And here in general, this epsilon r, relative permittivity, which is given as what we can say, and that equal to 1 plus this we can say chi, where this chi, which is called as the electric susceptibility, which is what we can call it as a susceptibility. Electric susceptibility. And here similar to that, mu r, which is given as 1 plus chi m, where this is called as a magnetic susceptibility. Okay. Electric susceptibility and magnetic susceptibility. Yes, these are the basic terms we use in our chapters very frequently. Okay. Now, you can have a look at now here in these terms. अगर आपने ध्यान से देखा तो all the terms you see this thing here, we have EDHB. EDHB. How these terms are, you can see now. These are vectors or scalars. And what these terms are, vectors or scalars? All these are the vectors. What these are? All these are what will be now? Vectors. So here vectors means, first of all, we need to find these parameters. We need to find, this is in the electric fields, we can see now E, that is D. Next, after that, we need to find this H as well as B bar. These four terms we need to find. All these terms are what element of vectors only. And to find these vectors, we need to have some fundamental knowledge of the some basic system, that is called it as what element of here. We should have a strong foundation of the coordinate systems. Strong foundation of the coordinate systems. The second thing is, you should be familiar with the basics of the vector calculus. And those vector calculus will plays a very important role in this topic. Okay, so that's why before entering into our subject, we'll focus about these coordinate systems and vector calculus. Okay, so this coordinate system vector calculus, whatever I'm going to discuss, all these things you already studied only. I'm just briefly revise these things once again. Okay, all these things I'll just revise. Okay, चलिए हम शुरू करेगा. Tell me now. Yes. Let's start now here. Coordinate systems हम शुरू करेगा. आला फिर दिल बना लो. So here now the basic things हमने शुरू किया अभी तक. Let's start now here. So दिल बना लो सभी ने आपका. चलो, here we are going to discuss about the three coordinate systems. One is a Cartesian coordinate system, cylindrical system, and spherical system. Yes. Yes, whatever we are going to discuss in the coordinate systems and vector calculus, each and everything you already know. I will just briefly brush up the things. Okay. So here these coordinate systems will plays a very important role to solve the problems. इसलिए हमने बहुत अच्छे से डिस्कस करेगा ये टॉपिक्स. सबसे पहले हमने कार्टेशियन कोऑर्डिनेट सिस्टम हम शुरू करेगा. चलो आज हमने कार्टेशियन सिस्टम का शुरू करेगा. ठीक है, ठीक है. टेक दिस थिंग, कार्टेशियन सिस्टम, कार्टेशियन कोऑर्डिनेट सिस्टम्स. Cartesian coordinate system. So you can see now Cartesian coordinate system now here in this case. In Cartesian coordinate system, the coordinate axes are, we can see it as what element now here, x comma y comma z. X comma y comma z, Cartesian coordinate systems. X comma y comma z. Here we have taken this axis. You can see now here, this is x axis and this is y axis and this is the z axis I am considering here. Let us say this is x axis and this is y axis and this is z axis, and here is the origin is there. Okay. Now, can you interchange the axis? Yes, we can interchange the axis, but we need to follow the order. You need to maintain x, y, z only. Okay, we should not jumble the order. Right-handed system we need to follow. Now, for example, if the given some point is given for you, let us say here some point that is x comma y comma z is given. How we locate this point? You tell me now. And we'll start at origin and we'll move a distance of x units along x-axis. This is x distance. Thereafter, we move to parallel to y-axis, a distance of what tell me now? Y units. Now these coordinates will become what? Tell me now here. X comma y z coordinate is 0. XY plane now. Thereafter we move a distance from this point, will take to up vertically. Okay. So then this distance, if I call it as from z axis, the distance is z. If I call, then we can call it as what? Tell me now. X, Y, Z. So for easy convenience purpose, what I am doing is, I am taking this axis, I am considering it as a z axis is a confusing now. So easily we are taking it as what? Tell me now here, this one I am considering. So this is x axis and this is y axis, this is z axis I am considering here. Now you tell me how we locate. Now first we will move a distance of x units parallel to x axis. This distance is x. Thereafter we will move a distance of y units parallel to y axis. This is y. Now if you see now here, what are the coordinates of this point? To tell me now here, x comma y comma z coordinate is how much now? 0. X, y, z coordinate is 0. Okay. Now thereafter we have to move a distance of how much now? Z units, which direction? Parallel to z axis. Like this. Now this distance which I moved now here, z distance. Now this is the coordinate of what? Tell me now here, point of x comma y comma z. Understood this one? Right. X, Y, Z. Done. Now unit vectors. What are the unit vectors we'll consider in the Cartesian system? You see this thing here. So different unit vectors, we use the different notations now here. This is I cap. You can use the J cap and K cap. These are the unit vectors. And so you may use this thing as what? Tell me now here. Let us say X cap, Y cap, Z cap also can be used. Different textbook, they will follow different notations. Okay. And we use this unit vectors will preferable. We go for AX cap and this is AY cap and this is AZ cap. Whichever is convenient for you, you can use. And the angle between them is how much? This is 90 degrees. Angle between AX, AY, AZ, which is how much? You tell me now? 90 degrees. Okay. AX, AY, AZ, which is 90 degrees. These are the unit vectors. Next, Cartesian coordinate system, which is orthogonal, orthonormal and follows right-handed system. What is meant by orthogonal means what? So that is I dot I, which is equal to what? Tell me now here, 1. What is the I dot J is 0. So that means similar to that we can say AX cap dot AY. What the dot product between these two unit vectors is what? Tell me now, 0. The dot product of two different unit vectors of the same system is how much? 0. Next, what is this thing? AY dot AZ. Angle between them is 90 degrees now. So that's why dot product is 0. Next, AZ dot AX, which is equal to how much? 0. Next, orthonormality means what? Tell me now. Cross product of two different unit vectors of the same system is the third unit vector. Means like what we can say now? AX cross AY. AX cross AY, which is equal to what? You tell me now here? AZ. X cross AY equal to AZ. And so this means you can observe here, this is AX and this is AY and this is AZ. And you can see this thing here. AX cross AY, which is equal to AZ, AY cross AZ, which is equal to AX, and then AZ cross AX, then it is plus AY. If we move like this, then only it is a positive. If we move opposite direction, then it is negative. Okay. Done. Next. Differential length. Differential length. Differential length in the Cartesian system, that we write as dl, which is equal to, when I move from the one point to other point, there is a change in length along x direction, which I can say it as a dx, and this is along what direction now? Ax. Change in length along y direction is dy into ay, plus change in length along z direction is dz into az cap. This is a differential length along in the Cartesian system. Okay. Differential surface area. Surface area is a vector quantity, and in this case surface area is defined for the two-dimensional case. Area means, so you should have two parameters are required now. Length means only one parameter. Right. Now you can tell me now here, surface area, differential surface area in case of a tell me now xy plane. Surface area in case of a xy plane is how much we can say? X direction change in length is dx, along y direction is what? Tell me now, dy. And what the direction of surface area? That is perpendicular to both x and y. So which axis is perpendicular x and y? Z axis. So that's why we can say the direction is what we can write now? Z axis. This, which we can also call it as what? Tell me now, constant z plane. What we can say, this is xy plane is also called as a constant z plane. Now you can tell me now next ds in case of a yz plane. YZ plane. Tell me now, YZ plane is along y direction dy, along z direction is dz, and direction is perpendicular to y and z. That is given by what? Tell me now, ax na. So this is also called it as a constant x plane. Okay. Next, now you can tell me now ds in case of a zx plane. ZX plane, which I can also call it as what? Tell me now, constant y plane. So what we can write now here, this is dz and dx into direction is what? Tell me now, ay cap. Okay. This is the differential surface area. Next, now we'll talk about this volume also. Tell me the differential volume. Volume case, volume is what? Tell me now, three-dimensional parameter na. Volume is a three-dimensional. So for volume case, हमने क्या करना पड़ेगा? All the parameters required. X, Y, Z. All the change in length we have to consider. So that is dV, which I can say it as what? Tell me now here. So that is given as dx into dy into dz. Change in length along x, y as well as z also. Okay. This is in a differential volume. Right, this is about the Cartesian system. All these things are cleared. Now we'll enter into the next coordinate system, cylindrical coordinate system. For the cylindrical coordinate system, the coordinate axes are, we have rho comma phi comma z. Rho comma phi comma z. Okay. Now have a look at now here about this system. X and this is y, and consider I have taken, and this is z axis. We consider we have one point we have taken in the xy plane. Let us say the point which is like this here. This point coordinates are x comma y comma z coordinate is 0. So the point lies in xy plane, z coordinate is 0. Now you can see now here. This point px comma y, now I am converting into a polar form. Polar form coordinates you know na? Polar form coordinates are what, tell me now here? The distance between them we are calling it as r, and this angle we are calling it as theta. Then these coordinates, this Cartesian system, it will becomes as what, tell me now here? This is rho comma phi comma z. It will becomes what, tell me? Rho comma phi comma z. Okay. Rho phi. So z value 0, of course. The z coordinate is how much now? 0. Now what is rho here? And but here we have taken it as what, tell me now here? This is r comma theta comma 0 now. What is r is a distance from the origin to the point now, tell me now. This distance. What happened? Is it lagging? That is given as x square plus y square. And what theta you tell me now here? Theta is what, tell me now? Tan inverse of y by x. Right. What is r is called as a? R is the distance from point P to the origin. So the distance indication purpose we use a notation. We use the r. So instead of r, I am going for other notations. That notation I am taking it as a rho. Instead of theta, I am taking it as a phi. Now this is not a r comma theta now. Now this will becomes what, tell me now here? That is rho comma phi comma 0, isn't it? Now it is what, tell me now? Rho comma phi comma 0. So now we got this rho and phi now. Now we need to get the third coordinate. What third coordinate is a z is there. We need to get the z now. Let's get the z axis also. Now for this, I am rotating the complete system 90 degrees rotation. So now I am taking, this is x-axis, this is my y-axis, this is z-axis. Rotate complete system 90 degrees clockwise. Then what happens now here? So here this is xy. Now this is the xy plane now. These points will lies in which one now? Where now here? This is xy plane. This thing. Right. So these coordinates. The coordinates of this point which we have, this is what, tell me now this is? These coordinates are, this is rho comma phi comma 0. and this is rho, and this angle with x-axis is a phi. Okay, and we'll do the PYQ session. The special classes we are planning, special classes is running. You can watch the special classes. PYQs of digital networks, EMT, these are running. You can watch the special classes. Okay, now with this, origin as a center and draw as a radius. Draw one circle. If you draw a circle, the circle, it will come to be like this. Only this part of the circle, outside part only, which is visible properly. Remaining parts are inside. Now we can't see. We are seeing the one view only we are seeing. Okay. Now what I am doing is, all these points I am projecting to vertically up some height. I am projecting to some height vertically up. Now this point which is taken to some height of Z, and this point, all the points are taken to certain height I am taking, and this point is also I am taken to some height. All the points are taken vertically up some height. Now with this, now this center is also shifted by some height here. Now with this rho as a radius, and we'll draw one more circle. Here we are drawing a circle, we are drawing here, you can have a look at now. Then the shape, it will come to be like this, you can have a look at now. Shape will come to be like this, and which is in the form of cylindrical shape. Since all the points we have moved by a height of Z units now, Z, and this is Z. So now tell me the coordinates of this point now here, and which is equal to rho comma phi comma Z. Okay, rho phi Z. Okay, now this is the three coordinates we got it now. What is rho is now here? What we can call this rho is rho is nothing but radius only now. Rho is nothing but radius of cylinder. And what is phi? Phi, which is called as a azimuthal angle. Phi is called as what element of azimuthal angle, and Z is called as a height of cylinder. Okay. Okay. And here another important thing is, Z in the Cartesian system, Z in the cylindrical system, both are same. Same as Cartesian system. Okay. And if we see this thing here, this ranges. And so rho is a range now here, that is rho is a radius which can be lies between 0 to infinity, and phi which can be lies between what tell me now 0 to 2 pi. Z is a height now, so that is from minus infinity to plus infinity. And so the conversions, if you see, now what we can say now, x is equal to, so that is earlier we have x is equal to r cos theta. But here in place of r theta we have taken rho phi na. So that's why x is equal to, we can say this as rho cos phi, and y equal to what, tell me now, rho sin phi. And whatever z you tell me now, z in the Cartesian, z in the cylindrical, both are same only. Z in the Cartesian, Z in the cylindrical, both are same only. Okay. Now you can see now what about this rho value? Rho, which is equal to, we have seen already, square root of x square plus y square. And phi is equal to what, tell me now? That is tan inverse of y by x. And z equal to z only. And unit vectors. And the unit vectors you can see now, we'll take, earlier we have seen unit vectors are ax, ay, az. Here we'll take the unit vectors are what, tell me now? Aero cap, a phi cap, az cap, will take unit vectors. And the angle between them is how much? 90 degrees. Angle between them is 90 degrees. Next. And cylindrical coordinate system is a orthogonal, orthonormal, and follows right-handed system. Means what, tell me now? Cylindrical coordinate system orthogonal means what? Aero dot a phi. Different unit vectors is 0. A phi dot az, which is 0. A phi, sorry, az dot aero, which is equal to 0. Next. Now tell me now, orthonormality means what? Aero cross a phi, which is equal to what, tell me now? Az. Orthonormality. So cross product will use what, tell me now? Third unit vectors. हमने पे like a Cartesian system ने हमने देखा ना, like that. So this is aero cap, a phi cap, az cap. This is a cross product. If we move like this, then only it is positive. Okay. Differential length. Differential length. Differential length. Now the differential length in case of a cylindrical system. So that is given as what, tell me now? dl bar, which is equal to what, tell me now here? d rho into aero cap plus what, tell me now here? Rho d phi into A phi plus dz into Az. This is. So in case of a d phi, keep in mind rho d phi. Yes, EC इलेक्ट्रिकल दोनों के लिए एक कोर्स. Right. Next, differential surface area. The differential surface area, which could be given as, what tell me now here, in case of a cylindrical system. So you can tell me now ds. If they are asking about this as a plane, let us say rho phi plane if they are asking. Can you tell me now how we can say rho phi plane is a? So change in length is rho, along phi direction is rho d phi. So will come rho d phi, rho d phi into what we can say now here, this is Az cap. And what we can say now, this is called it as a constant jet plane. This is called it as what term of constant jet plane. Right. Now, so we have a ds in case of a, that is phi jet plane. Phi jet plane, which is equal to what term, rho d phi dz, and direction is perpendicular to phi and z, which is perpendicular arrow. So we can call this as what term, constant rho plane. This is called as a constant rho plane. Next, ds, which is z rho plane, and which I can also call it as what term, constant phi plane. So which is given as dz d rho into A phi cap. Okay. And tell me the volume case. So area means which is a 2D. But volume means which is 3D, na? Volume means which is a 3D. So tell me now 3D case. What we have, tell me now dV differential volume. We need all the change in length we need. Change in length along rho phi z also required. So we can say rho d phi and dz. Okay. The same manner we can even develop the spherical system also. Spherical system, here the coordinates are what you can see now here, r comma theta comma phi. Spherical system, r comma theta comma phi. Right. So here in spherical system, now if I call this is x-axis, this is x-axis, this is y-axis, and this is z-axis. Initially we have taken some point in the xy plane. Xy plane we have taken the point here. So these coordinates are what we can say now, x comma y comma z we have taken. Okay. So here z is 0 now. Why? Because the point lies in where you tell me now, xy plane. And so this distance, which is called it as a This distance is called it as a, this distance is a rho na, and this angle is called as a phi na, same as cylindrical system. Okay. Now I am projecting this point to certain height. I am drawing the projection of this point to somewhere here. Now this coordinates will becomes what, tell me now here, x comma y comma z. Some height we have taken now. This one. Now, so you tell me now what is this distance now here? Square root of x square plus y square plus z square now. The distance is calling it as a r, and this angle with the z axis we are calling it as theta. And with this radius, I am drawing one sphere. I have drawn like this. This is the sphere. Okay. Now you can tell me the coordinates of this point. What we can say now, this is r comma theta comma phi. R comma theta comma phi. Okay. Where what is r, you tell me now? R is a radius of the sphere. R is a radius of the sphere. And theta. Theta is called as an elevation angle. Theta is called as the elevation angle, and phi, which is called as the azimuthal angle. Phi is the azimuthal angle, and which is same as cylindrical system. Which is same as cylindrical system. Okay. Now you can tell me now this conversion relations now here. What is this r, you tell me now? R is equal to distance from origin to the point now, that is given as square root of x square plus y square plus z square. And what theta, you tell me now? That is given as tan inverse of what, tell me now here? That is rho by z. So here this angle, so if you draw one perpendicular line here, this coordinates are this distance. How much this distance is the z only na? So tan theta, sorry, this one, this one, this distance is z only na? So the tan theta, so here, so and then this is, this distance is z, this distance is rho na. This coordinates are what is 0 comma 0 comma z only na? That is tan theta equal to rho by z. So from the triangle, you tell me now tan theta, which is equal to what, tell me now? Rho by z. Sin theta equal to what, tell me? Sin theta equal to rho by r. Cos theta, which is equal to z by r. So from this, we can get now here rho equal to what, tell me now? Rho equal to r sin theta. Z equal to what, tell me now? R cos theta. Okay. From this phi, what is the phi now? Phi in the cylindrical, phi in the Cartesian, both are same. So that's why same formula. Tan inverse of what we can say, tell me now? That is y by x. Okay. Done. Next, ranges. So here R is a radius. The range of R is 0 to infinity. Theta can be lies between way to way 0 to pi. Phi value can be lies between what we can say now 0 to 2 pi. Okay. Now here also we'll write the unit vectors. What are the unit vectors we can take? You tell me now. This is AR cap, A theta cap, A phi cap. And angle between them is how much? 90 degrees. Spherical system is also orthogonal, orthonormal and follows right-handed system. So means what I can say now, orthogonal means AR dot A theta, which is equal to 0. A theta dot A phi, which is equal to 0. A phi dot AR, which is equal to 0. Next, AR cross A theta, which is equal to A phi. A theta cross A phi. A theta cross A phi, which is AR. A phi cross AR, which is equal to A theta. Okay. So if we move in this order, we'll get positive. Opposite order will get the negatives. Next, here also we'll write the differential length. Tell me the differential length in the Cartesian system. So dl, which is given as what? Tell me now. Dx into ax cap plus dy into ay cap plus dz into az cap. And differential surface areas. Like in the Cartesian system we have seen, cylindrical system. This is the system we have seen. And what a spherical system, you tell me now here. dl is a like dr into ar cap plus what? Tell me now. So here next one is what? Tell me now. R d theta into a theta. Next, r sin theta d phi into a phi. Is it fine? And differential surface area, and which is given as ds, it should be equal to, in case of a r theta plane, what I can say here, r d theta into a phi, and we can call this as a constant phi plane. Next, ds, which is given as what we can say now, theta phi plane, and which is equal to r squared sin theta d theta d phi into ar cap, and this is also called as a constant r plane. Next, ds, which is equal to phi r plane, and that is constant theta plane. Tell me now this one what will get, which is equal to r sine theta d phi dr into a theta. And what about differential volume? Volume case, how many parameters required? 3 parameters required. So all we need to multiply now dV, which is equal to what? Tell me, r square sine theta dr d theta d phi. Okay, this is the spherical system. Oh, ho, 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 la, la, la. Oh. Yeah, this course is for both EC and electrical दोनों के लिए. ये पूरा बात कहानी समझ में आया सभी को बोल. Now we'll simply summarize the things now. एक बार ध्यान से देखो इधर. Yes, now Cartesian system we have x, y, z. So we can say dx and this is dy and this we can say it as whatever dz. Change in length. Along this rho cylindrical system is what element of d rho and this is rho d phi and this is dz. And spherical system, that is what element of dr, this is r d theta and this is rho means r sin theta. So that is r sin theta into d phi. Okay. Remember this thing. With this we can write anything we can write. Length, area, volume we can write easily. If somebody asks the volume in the cylindrical system, what we can say will multiply rho d phi dz. Okay. And volume in the spherical system will multiply all these things. R square sine theta dr d theta d phi. Okay. Done. This is about the coordinate systems. Now we'll enter into the next one, that is called as a vector calculus. This is the summary. These are short notes. The student who are following them, for them you will get the short notes also. Complete short notes bhi aapko milega. You can have a look at now short notes. And I think all of you know how to get the notes and all. And in the Telegram you message me. You can search in the Telegram. You can see this thing, my profile, that is BB Reddy sir. In the Telegram you can get my profile. So from there you can able to contact us. You can message me there in the Telegram. You will get the complete notes आपको मिलेगा. Short notes, DPP, assignments, सब कुछ उधर मिलेगा आपको. चलो. Next one. Vector calculus. In this vector calculus, what we are going to discuss, here, the terms vector integrations, vector differentiation and vector theorems हम बात करेंगे इधर. Vector integration, vector differentiation and theorems. Okay. Let's see one by one. First we'll talk about the vector integrations. Vector integrations. Vector integration. If we have this is integral of a bar dot dl is there, what we can call this is, you tell me now? And this is called as a line integral. This is called as what we can say, this is a, this is called as a line integral. Right. Line integral means we are finding the integration of one parameter from here to here. This is the line. Let us say the point P to Q I am moving. This is a line integrations. If the path is a closed path, means P to Q again Q to P, वापस P पर आया, then this is called as a closed line integral. How we can indicate with the bubble? Closed line integral of a bar dot dl, and this is called as a closed line integral. Okay. Now, if I ask him to find the integration of some vector, surface integral, then we can say this as a bar dot ds. This is called as a surface integral. And if the surface is a closed surface, then we can use this bubble of what we can say now, a bar dot ds bar. And this is called as a closed surface integral. Okay. And in case of a volume case, so this is volume integral of mod A into dV. This is called as a volume integral. Okay. The line integral, by default line integral means this is also called as open line integral. Surface integral means by default it is an open surface. Okay. Line integral, open line integral, closed line integral. Open surface, closed surface. Okay. Line. You can see now line means, so if you are finding the integration of one parameter from A to B, let us say A to B we are finding here. This is called as what, tell me now, line integral. This is called as a line. If this is a closed line, means I am moving from A to B, again B to C, B to C, C to D, again D to A. So this is the called as a closed line. This is called as what, tell me? Closed line. And this closed line, if you see, it will is nothing but it is forming certain, this part of area is occupied, isn't it? This part of area is occupied. So this is called as a open surface. This is called as what, tell me? Open surface. Now you can see now this is if we have taken, this is my one open surface. Now we have closing from all the sides. This side we have closed, this side, top, and this bottom we have closed. Then this is called as what? Tell me now. This is called as a closed surface. This is called as closed surface, and this closed surface will forms what? Tell me. It has a volume. This closed surface, it has what? You tell me now. Volume. Okay. Now you can understand. You tell me now here. Closed line. This is nothing but open surface. Closed surface is nothing but what? Tell me now. Volume. Okay. You can copy this thing. Closed line is nothing but what? Tell me. Open surface. Closed surface is nothing but the volume. Okay. Yes, EC also na. This force is for EC also. Done. So basically, line. Line means what? I'll be now 1D figure. Okay. Closed line. Closed line, which is a 2D figure. Two-dimensional figure. Closed line will forms what? Tell me. Open surface. Next. Closed surface. And which is a 3D figure. It will forms a volume. Okay. Any 1D figure is a line. Any 2D figure is a closed line. Closed line means it should be definitely an open surface. Any closed surface is a three-dimensional figure. The shape can be anything and it will forms a volume. Okay. Done. Now let's talk about the vector differentiation. Previously we have seen vector integration. Now I will talk about differentiation. Vector differentiation. The first one is a gradient. Gradient of a scalar function. The gradient of a scalar function is a vector. Gradient of a scalar is what? Tell me now, which is a vector quantity that gives both magnitude and direction of the maximum space rate of increase of V. Maximum space rate of increase of V. That is a gradient. So means let's understand mathematically. So gradient will denote it as a gradient of V. This we can write it as simply del V. Gradient of V, which is equal to del V. Gradient of V, which is a nothing but vector, It gives what, tell me now here? Gives both magnitude and the direction of the maximum space rate of increase of V, and that is what we can say here, that is dou V by dou X into, this is the variation of V with X, and that is along X direction, so that's why AX cap. The variation of V with respect to Y and along the Y direction, and variation of V with respect to Z along Z directions. Okay, this is the variation of the physical phenomena with respect to space parameters, which is called as a gradient operations. Okay, this is a gradient we have seen the Cartesian system. This is the Cartesian system now, right? Divergence. Divergence means what, tell me now? So here the divergence means what, tell me now here? It is a measure of the net rate of flow from a given point. The measure of net rate of flow from a given point. That means divergence will denote this as a divergence of A, and which is given as what we can say, tell me now here? This is del dot A bar. Del dot A bar, which is given as divergence of A. Basically, the divergence means what, tell me now here? Leaving nature. If anything is leaving, we can call the nature is called as a diverging nature. Diverging nature, leaving nature, expanding nature, moving away nature. So what we can say, if we put a hole to balloon, then air will diverge. If I put a hole to the water bubble or water can, then it will be a water will move outside. Living nature is called as a diverging nature. Okay. If anything is living, we can call that is a diverging field. And this concept of divergence you need to understand properly in this subject. So as you might be know, in entire our discussion of EMT, we should focus about the four major equations. What are those? Those are called as a Maxwell's equations. Among the four Maxwell's equations, two Maxwell's equations are based upon the divergence concept. So इसीलिए divergence phenomena is very important concept you need to understand. Okay, सुनिए now, what are the terms, what are the equation based upon this one divergence? The one are the Maxwell's equation, which is del dot D, and which is equal to rho V. Del dot D equal to what, tell me now? Rho V. And the other equation, which is equal to what, tell me now? Del dot D, and which is equal to 0. Del dot D equal to 0. Del dot D equal to rho V, and del dot D equal to 0. Now you can see, have a look at now here. Now D, what the D is the electric flux density, which is given as D is equal to epsilon E na. If I place it now here, so will come it as del dot of epsilon into E, which is equal to rho V, and epsilon to other side, then will come it as del dot of E bar, which is equal to what, you tell me now? Rho V by epsilon, which is equal to rho V by epsilon. Okay. Now this is one Maxwell's equations. Now other thing here, B is equal to what? Tell me now here. B is equal to mu H. And we can write as what? Tell me now here. Del dot of B is equal to mu H, which is equal to 0. Mu to other side, then will come it as what? Tell me now. Del dot of H, which is equal to 0. So you can observe here carefully. Here you need to focus about here. In this case of this electric field, divergence of electric field is non-zero. But whereas divergence of magnetic field is 0, you need to observe this point, you need to observe here. Why the divergence of electric field is non-zero and why it is 0 in case of a magnetic field? This phenomena you need to focus here. Okay. Now look at now here. And if you have considered, in a positive charge we have considered, tell me now how it is. If we have taken some charge, we have taken some positive charge, then how we have the electric lines, you tell me now. How the electric lines you can see now, those are like this. Electric lines which are radially outward in all the directions, you can have a look at. Right. So what is this nature is called as? What is this nature? How these electric lines are leaving now? How this one? These are what you tell me. These are nothing but electric field lines only now. This is nothing but electric field only. And how these electric field lines are now? Tell me now. Leaving nature, diverging nature now. So that's the reason the divergence of electric field is non-zero. That's why the divergence of electric field is non-zero. Understood? Whereas when you have considered this as a conductor, when you have taken, so if there is a flow of current through the conductor and we have a magnetic lines now, you see, and we have this magnetic lines. This is the magnetic lines. How the magnetic lines, you tell me now? These magnetic field lines are around this conductor. Is this magnetic lines are leaving? Is the magnetic lines are leaving from this conductor? No, these are not a leaving nature now. So that's the reason what I can say now, the divergence of magnetic field which is equal to 0. So here the electric field lines are diverging nature, diverging field. That's why the divergence of electric field is non-zero. But whereas magnetic field is not a diverging nature. So that's why the divergence of magnetic field is 0. Is this point you understood? Tell me. All of you tell me this thing. Is since electric field is a diverging nature, diverging field, that's why the divergence of electric field is non-zero. But magnetic field lines are not diverging now. Magnetic lines are always around the conductor. Those lines cannot move away from conductor now. So that's why the divergence of magnetic field is always 0. Okay. And in general, the divergence of a vector quantity, it may be positive or it may be negative and it may be 0 also. The divergence of a vector quantity may be positive, may be negative and 0 also. The divergence is positive in case of source, negative in case of a sink, and 0 in case of neither source nor sink. Okay. Okay. Now you tell me now here in this, for example, if I have seen, I have taken some point now here, how at this location. So if we have like this, what is the divergence now here in this case at this point? Here the field is leaving now. So this leaving field, so that's why diverging field only now. So that's why what I can say now, divergence del dot A, which is not equal to 0. Okay. Next. Here this field, the field is like this, isn't it? Now here in this case, how the field is now here entering now. So that's why in this case, divergence is what I can say, tell me now, negative. Yes, in this case, positive I can write non-zero, and then it is positive. Here it is non-zero and it is negative. Now, if we have the some other case, the field lines are like this. Consider. We have the field lines are like this. Now you can tell me in this case what will happen. Now, if we see this thing at this point, so here the field lines are coming and going. This point from this point does not giving, does not taking. If we talk about this point P, what is the divergence at the point P? You tell me now. Jitna field left say Ara, utna field leave. It is leaving. So the point P is not at all contributing anything, isn't it? So that's why the divergence at this point P will becomes what, tell me now? Which is equal to 0. Okay. Now if I call this is M, this is P, this is N. You can tell me now what I can call this M is now, tell me now. M, so I can say this is the source I can call now. And then N is what, tell me now, sink. And whatever the P is a neither source nor sink. So that's why which is divergence is 0. Okay. Okay. And this divergence of a vector which is given as del dot A, that is given as dou AX by dou X plus dou AY by dou Y plus dou AZ by dou Z. Okay. Done. Next, curl of a vector. Curl of a vector. What the curl means? What? Tell me now. It is a measure of how much field or flux rotating about a given point. Flux rotating about a given point. Okay. Now this curl of a vector will denote as a like this. Curl A. So this we can write as what will be now del cross A. And previously we have seen the divergence. Divergence means what will be now leaving nature. And curl means what will be now rotational nature. Rotational nature. Here how the field is rotating. Now you see this thing. Previously we have seen two Maxwell's equations which are based upon the divergence concept. In the four Maxwell's equation, two are based upon divergence, remaining two are based upon curl concept. Isliye curl is also very important. All of you listen carefully. And the two equations are, of course, we are talking about the static fields. For static fields, so what we have, tell me now, del cross E, which is equal to how much? You tell me now, 0. And the other equation is what? Tell me now, del cross H, which is equal to J. Here how we got what is this you will get to know later, but अभी ने आपको क्या किसके बारे में सोचना पड़ेगा? So where E is the electric field, why the curl of electric field is 0, why it is non-zero in case of magnetic field, that you need to focus here. Okay, what the curl means, what I will now basically this is a measure of how much field is rotational. अभी ने हमने देखा, so how the electric field nature is a leaving nature, expanding nature, try to expand this entire region. That is electric field is what type of field is a diverging, it is not a rotational nature. Since it is not rotational, that's why its curl is 0. But magnetic field is how it is, you see, and magnetic field lines are always a rotating nature now. That's why the curl of a magnetic field is non-zero. Is this point clear, you tell me? And previously we have seen the other equation, those also will summarize here. That is what, tell me now, we have seen del dot E. What the del dot E we got, you tell me now? That is rho V by epsilon naught. And here del dot H, which is equal to how much? 0. Yeah, you tell me now from this equation what you can able to conclude, you tell me now. From these two equations what I can talk about nature of electric field is. From this equation what I can say in electric field is what type of field is a electric field is a diverging field, but it is not a rotational field. And from this what I can say now, magnetic field is a rotational field, but it is not a diverging field. Understood what I am saying here? Electric field is a diverging but not rotational. Magnetic field is a rotational but not diverging. Isn't it? Right. So from this what we can conclude, you tell me now here. Static electric field. What is how the static electric field is? Static electric field is diverging. Diverging but not rotational. But not rotational in nature. And what about this magnetic field, you tell me now? Magnetic field is what type of field is a rotational. Magnetic field is a rotational but not diverging. Okay, is this point clear to all of you? And how will find the kernel of a vector? Del cross A. We can do it as what element here? Ax. Like ijk, we can write as what ax, ay, az. Ax, ay, az. By determinant method we use now. So that is dou by dou x, dou by dou y, dou by dou z. Next we have ax, this is ay, and that is az. Okay. Done. Next we'll talk about the vector theorems. Vector theorems. First one is Stokes theorem. So Stokes theorem is what element for example. So if they ask him to find the closed line integral of a bar dot dl, we need to find. And let us say the closed path they given as like this. This is the closed path is given. So here they are moving like this. Let us consider this is a closed path. Let us say this I am calling it as first path, this I am calling it as second path, this is the third, and this is the fourth. By joining all, we'll get the closed path we got. Right. Now close line integral of a bar dot dl. What will come, you tell me now here. So to find out now here, we need to split it as first path integration of a bar dot dl plus second path integration of a bar dot dl plus third path integration of a bar dot dl plus fourth path integral of a bar dot dl. This thing we need to do it now. Now, so here we need to find this value. We need to do the four integrations we need to do here. So instead of doing this four integral, as we know, this is the closed line. This closed line is forming what terminal? Open surface. This closed line which is forming a open surface is forming now. Based upon this property, we are converting this closed line integral converting into a open surface integral. That is what tell me now here. Closed line integral of a bar dot dl, and which is equal to what we can say now, open surface integral of del cross A dot ds. Del cross A dot ds. This is the way we can do it now. Okay. So by using Stokes theorem, what we did now here, the closed line integral converted to what, tell me now? Single open surface integral we converted, isn't it? This is the Stokes theorem. By using Stokes theorem, closed line integral is converted into open surface integral and vice versa. Okay. Right. Next one, divergence theorem. What we can do this divergence theorem means, so if I want to find the closed surface integral of a bar dot ds, I have to find, and which is equal to, so this could be given as, let us say this, let us consider the Q we have considered as a closed surface. It has how many open surfaces? Will have 6 open surfaces now. First open surface of a bar dot ds, okay, plus second open surface of a bar dot ds, plus third of a bar dot ds, plus this fourth of a bar dot ds, plus fifth of a bar dot ds, plus sixth of a bar dot ds. We need to split it as 6 open surface integrals now. Instead of doing all these many integrals, we are converting this closed surface is nothing but volume now. Based upon that, this closed surface integral we are converting into a single volume integral of a bar dot ds, which is equal to what, tell me now here, volume integration of del dot a into dv. Okay. Done? Fine. By using divergence, what we did now, we converted the closed surface integral is converted into open volume integral. Closed surface to volume integral and vice versa. Now let's see some important points here. Now see this thing. Note. So you tell me now, if divergence of a vector is 0, then what we can call that vector is a? What we can call that vector is a solenoidal. What we can call that vector is a solenoidal, or we can also call it as a divergence free vector. divergence free vector. Okay. Next you tell me now, if curl of a vector is 0, then what we can call that vector is a, then that vector is called it as what tell me now, irrotational vector. Irrotational vector, also called it as a conservative. Conservative. Okay. Next. And conservative means what? Independent of the path. Line integral independent of path, then we can call that as a conservative vector. Means if line integral is independent of path, then it is called conservative vector. Okay. For conservative vector, closed line integral of a bar dot dl, which is equal to 0. If it is conservative vector, closed line integral of a bar dot dl equal to 0. Okay. Next. And we have vector identities. We have, those are, one is the divergence of curl of any vector. The divergence of curl of any vector is always 0. What we can say in the word statement also important. The divergence of curl of any vector is always 0. The divergence of curl of any vector which is always 0. Okay. Means, for example, if we have taken this vector, we have taken A is some vector. Any vector will have two natures. It has a diverging nature as well as a rotational nature. Now, if I did the first del cross A, I did. Del cross A is what, tell me now? It is the amount of vector having what nature? Rotational nature. If I did del cross A, हमको क्या मिलेगा? Which is having only rotational nature. Which is rotational nature here? Only A are having rotational nature now. Then after that, we need to do it as del dot of del cross A we need to do. That is what, tell me now here, del dot of del cross A is what, tell me now, AR. What is AR you tell me now here? This is a vector having only what nature? Rotational nature. We are finding divergence. Divergence of rotational vector is how much? 0 na. This AR has the purely rotational nature only. So that means what is the divergence of a rotational vector? Like we can say even part of odd signal is how much? 0 na. Even part of odd signal. Similar to that, diverging part of a rotational vector, how much will become? 0. Understood this point? Tell me, all of you. Hmm? Next. Other one we have the curl of, similar to that, the curl of gradient of any scalar which is always equal to 0. The curl of gradient of any scalar which is always equal to 0. Okay. The curl of gradient any scalar is 0. Okay, these 3 and 4, these are called as a vector null identities. 3 and 4 are called it as what? Vector null identities. Okay. Done. Let's see some problems now to understand these concepts. Take this problem. The value of close integral of dl. Here this dl is what, tell me now? Is a scalar. So we cannot apply the Stokes theorem here. Length only now this is. So here this is dl is given. So along a circle, total length. So I have taken, this is the radius, which we can say this is r. If I call radius is r. If you have taken small length, we have taken this length is called as a dl na. This length is dl. How much this dl equal to what? Tell me now. Rho into d phi. Rho into d phi na, change in length along the phi directions. Okay, length is same. So means we can need to find now here, this is integral of dl, which is nothing but integral of rho into d phi. Here the rho is nothing but radius. Okay, into d phi. Here the phi limits are what? Tell me now. 0 to 2 pi. So this is, that is, rho is nothing but r only now. R into d phi. Phi limits are what? Tell me now. 0 to 2 pi. Now simplify now here. R into integral of d phi equal to phi na. Limits are 0 to 2 pi. So it will come to be a what? Tell me now here. That is 2 pi r. So that is equal to 2 pi into r is given as 4 na. So this value will come to be 8 pi. Okay. Next, take this thing here. The region specified by rho phi z in cylindrical coordinate has a volume of. The given cylindrical system given na cylindrical system. So this is volume they are asking to find. Volume, what we can say now, integral of dv we can say now, volume integrations, and which is equal to volume integral of dv equal to what, tell me? So we have rho comma phi comma z. Change in length along rho direction d rho, along phi direction that is rho d phi, along z direction dz. So which is equal to volume integral of rho d phi and dz. So you can tell me now rho limits. So this is rho limits are what, tell me now here? They given 3 to 5 into rho into d rho, and phi limits are what, tell me now? Pi by 8 to pi by 4 into d phi, and z limits are what we can say, tell me now? 3 to 4.5 into dz. So simplify this thing here, will come it as what, is now rho square by 2, limits are 3 to 5, and this is phi, limits are what, will be now pi by 8 to pi by 4. Z only na, limits are what, will be now 3 to 4.5. Now simplify and get it. So will come the volume. So how much will come here? Rho square, that is 25. Okay. So this we can say 1 by 2 into 25 minus 9, and this value I will write in below here. So this volume, which is given as 1 by 2 into 25 minus 9, and then pi by 4 minus pi by 8. Next, 4.5 minus 3. We can simplify now. How much will come this value? 25, that is 16 by 2. This is how much now? 8 is LCM now here. So this is pi by 4 only na, and this is 3 by 2. So how much will come, you tell me? This is 4.7. Check it. Next, consider a closed surface S having volume is V, R is a position vector, n cap is unit vector. The value of the integral is. In the problem, what they asking to find, first of all, convert into our notations. Closed surface integral of 5 r bar dot ds bar. This is the mathematics, they use this type of notations. Will convert into our notations. Now here we have closed surface integral is there now. Now 5 outside we have taken. Now we are applying the divergence theorem. That is volume integration of what I can say, del dot of r bar into dv I can say now. What it is, r bar is a position vector, which is given as xi plus yj plus zk na, and we need to get what element of del dot of r bar, which will come to be a 1 plus 1 plus 1. So which will come to be a 5 into volume integral of 3 into dv. So which is equal to 15 into volume integration of dV, which will come to be a 15 into volume is V given na, so 15V. Okay. Next, they given in this case D is given, they ask him to find the closed surface integral. Here also we can do the same approach. Now we need to apply the divergence theorem, we will simplify it. So tell me now here closed surface integral of d bar dot ds, and which is equal to what? Tell me now here volume integration of del dot d into dv. Now you can tell me now here we should find the divergence, we should find a del dot d. So cylindrical system divergence is 1 by rho into d by cylindrical system now. So this is dou d rho by dou rho plus 1 by rho into dou by dou phi of rho so in this case 1 by rho into dou by dou phi of rho into d phi plus dou dz by dou z. So tell me now here we have only d rho and dz only, no phi term. So differentiate now here dou by dou rho of 2 into rho square plus this is 0 plus dz, this is 1. And what will come here? Del dot d, which will come to be a 4 rho plus 1. Okay, this one. Now this is del dot d, which we got it as what will be del dot d, which is equal to 4 rho plus 1. Now we place now this thing in this here. So that is closed surface integral of d bar dot ds, which is equal to volume integration of 4 rho plus 1 into dv. And differential volume in the cylindrical system we know now 4 rho plus 1 into what I can say now. So this is rho d phi dz. Okay, now you can tell me now this thing. So this is rho, that is rho is from 0 to 1, will come it as 4 rho square into d rho, and then phi terms 0 to 2 pi, this is d phi, and z is what? Tell me now here 0 to 5 into dz plus 1. So this value rho is from 0 to 1 and phi is from 0 to 2 pi, and z is from 0 to 5. This is rho d phi dz. How much will come, you see? D bar dot ds, which will come to be a what? Tell me now here this thing. Integration of 4 rho square. It will come it as 4 rho cube by 3. Rho limits are what? 0 to 1. So 0 to 1. Next 5 terms, that is 2 pi na z 0 to 5. So this value 5 will come na 5 plus, and this is rho, this is 1, this is 2 pi, and this is 5. Tell me now here 4 by 3 into 10 pi plus 10 pi. How much is value? 10 pi we have taken common. 4 by 3 plus 1. So 10 pi into what terminal? 7 by 3. Which will come it as 70 pi by 3 na? Check it all of you. Calculation कोई गलत तो नहीं किया? Now try to answer this thing. And here they given x, this is y, this is z. So you tell me now, in this case, first figure you tell me now divergence is 0 or non-zero. First figure here, this is del dot of x, which is non-zero na here. Why? Because it is a diverging only na. Next here in this case, what tell me now here? So in this case, curl is non-zero. It is rotational na. That's why curl is non-zero here. And the fourth case, you see this thing, how this field you tell me now here. It is diverging as well as rotational also. So divergence is non-zero and curl is also non-zero na here. Curl is also non-zero. So then which could be the option you see? Divergence 0. So first one, no. Divergence is non-zero, curly. This is also no. Divergence is non-zero. Yes, this is correct. C. Okay. Isn't it? Yeah, you tell me this thing. If the curl of a vector is 0, then what we can say that vector is a irrotational. So this is here now. So for this is 2. Divergence is 0 means solenoidal. So 3. Divergence of gradient is that is a Laplacian. So this value which is 1. Divergence of divergence not valid. So this is 4. 2, 3, 1, 4. 2, 3, 1, 4. Option A. Find the value of A such that the vector is a solenoidal. Solenoidal means what tell me? Divergence must be 0. So then apply this condition, find out the A value. For solenoidal, divergence of V which is equal to 0. Apply this condition, tell me now. So if you differentiate now, this is 1 plus y, 1 plus A which is equal to 0. So A equal to how much you tell me now? Minus 2. Okay. Next. See this one here. They given some scalar function. They asked him to find what, tell me now? The curl of gradient of a scalar function. What is the curl of gradient of any scalar function which is always equal to 0? Curl of gradient of any scalar function is always equal to 0. So then what's the option you tell me now? D. Okay, fine. Okay, with this we have finished the basics of this EMT, and the next class we'll do the electric field, magnetic field, some discuss करेंगे. ठीक है? Okay then, see you. Bye bye.